the laboratory. Today I'll be making concentrated acetic acid using sulfuric acid's action on anhydrous sodium acetate, which I made in a previous video. When the two are mixed together, an equilibrium is set up, as shown here, and you can see that since acetic acid boils at 119 Celsius and sulfuric acid boils at around 300, the mixture, or the acetic acid, is easily separated from the mixture by boiling. And so that's just some simple distillation that we can do. There's a couple things you need to watch out for when you're running this reaction, and I'll get into that a little bit later. And the reason also I say here that we're not making glacial acetic acid, as I've seen in a lot of other YouTube videos, is that the acetic acid that comes off is not quite anhydrous and free of water, since the sulfuric acid I'm using is approximately 93%, and the sodium acetate, while fairly anhydrous, isn't completely dehydrated. And there are ways to further dehydrate acetic acid, which I'll get into in a separate video. But for the most part, concentrated acetic acid at greater than maybe 95% water is suitable for most purposes. So let's get started. I'm running this on a 2 molar scale, so I need to place 164 grams of anhydrous sodium acetate into a round bottom flask. This flask here looks very, very full, and that's just because the sodium acetate is very fluffy. Once the sulfuric acid is added, this packs down to a little over halfway, which is about a safe point for a 500 milliliter round bottom flask, or any round bottom flask for that matter. The addition of the sulfuric acid is exothermic, so we will be boiling some of the acetic acid out into the room if we just simply add it to this flask. So instead I'm going to set up for distillation with a separate funnel to add the sulfuric acid with the distillation setup in place. That way I can capture any of that comes out. So I'll do that now. The apparatus is now set up. I have the 500 milliliter round bottom flask with the anhydrous sodium acetate in it down here in a heating mantle. A Claisen adapter on top of that, with in one arm a flask, or an addition funnel of concentrated sulfuric acid. This is 264 grams of sulfuric acid, and that's compensated for both a 1.25 times excess with respect to sodium acetate, which helps further dry the acetic acid, as well as it's been compensated for its concentration, which is, I believe, somewhere between 93 and 95% last titration. In the other end of the Claisen adapter, of course, is my still head, and this is just the thermo well, so I can use a digital thermometer. It shows up better on camera. You can see we're reading about 14.8 C right now. I have a 200 millimeter Liebig here with the water on, and of course my vacuum takeoff and the receiver. We'll now slowly start adding the sulfuric acid to the anhydrous sodium acetate. And you can see the effect that the acid has on the sodium acetate, immediately generating an exothermic reaction and causing a lot of packing. You can see there are some vapors rising. So it starts boiling, and we'll start collecting some acetic acid. And that's the last of the acid. And as you can see, we already have a significant amount of reflux happening in here of acetic acid. And it's already boiling. The heating mantle's not on. It's very, very hot. You can see the temperature's reading 86 C already. So we'll just turn on the heating mantle and just keep this flask gently warmed, and the acetic acid should distill over. The mixture is now boiling, and you can see there's a bit of reflux happening up here. And the first vapors are just now about to reach the condenser. And pretty soon, acetic acid will start to collect in the receiver. As the distillation proceeds, less and less solid will be seen in the flask, and eventually it will only be a concentrated solution of sodium hydrogen sulfate and sulfuric acid. It's advisable to wrap the still head with a towel or some other non-flammable insulating material to increase the rate at which the acetic acid boils from the solution and decrease the rate of reflux. You can see we've already collected approximately 120 milliliters of nearly glacial acetic acid. The reaction is now essentially completed, and you can see that the contents of the boiling flask have turned into a thick, brown-colored, slowly boiling liquid. There's still a little bit of acetic acid in there, and you can see it rolling down the walls of the flask as it cools off. And that's okay. We've recovered the vast majority of it, and it's going to be impractical to heat this to a high enough temperature to recover the last of the acetic acid. Here's a final yield of nearly pure acetic acid. It's not quite glacial because glacial acetic acid melts at about 16 degrees C. I took the melting point of this and it melts at right around 7.8 C. And if what I read in literature is correct, that means that this is almost 96% acetic acid. So not quite anhydrous, but it is very concentrated acetic acid. And for most purposes that require acetic acid, for most experiments that require acetic acid, 95% is just fine, or 96%. This can be made glacial by refluxing with acetic anhydride or something like that, which I'll do in a later video to make true glacial acetic acid. But for now, I'll store this in a bottle and call it concentrated acetic acid at roughly 96%. I'll be using this in a number of upcoming videos, so I thought I'd show you how to make it, or how I make it. You can also buy it online. You can buy glacial acetic acid online, and it's really not that expensive. But if you can't do that, you can always make it. Anyway, I hope you enjoyed the video. I had a lot of fun making it. And as always, please subscribe, like, and comment.